Now it's your turn to do some evaluating and solving involving function notation, with functions given in different forms. If you've not tried this example on your own already, please pause the video, return to your lecture notes, complete this on your own, then return to the videos to check your work. We are given three separate functions. F of x is negative 2/3 x plus 7, g of x is defined by a graph, and h of x is defined by a table. In part A, we need to evaluate f of negative 6. It is important to recognize that because we have three separate functions, each one needs to have a separate name. So when we are asked to evaluate f of negative 6, we need to identify that we are working with the function f of x equals negative 2/3 x plus 7. Additionally, when we are asked to evaluate f of negative 6, we need to recognize that that negative 6 is an x value. So in being asked to evaluate f of negative 6, I'm simply being asked to substitute negative 6 for all the x's in the function notation. When we substitute negative 6 for the x on the negative 2/3 x, don't forget to maintain your multiplication between the negative 2/3 and your x value. So f of negative 6 is negative 2/3 times negative 6 plus 7. At this point, we need to use order of operations to simplify the expression. To multiply negative 2/3 times negative 6, we'll think of it as negative 6 over 1, and a negative times a negative is positive. 2/3 times 6 over 1 would be a positive 12 over 3 plus 7. 12 over 3 is 4, and 4 plus 7 is 11. So f of negative 6 equals 11. In part B, we are asked to solve the equation f of x equals 9. Again, in being given f of x, we know we're working with the function f of x equals negative 2/3 x plus 7. This time, the 9 that we are given is not an x value. If it were an x value, we would not have x still in our equation. Since it is not an x value, it must be a y value. And since it is a y value, and is equal to f of x, we will simply replace the f of x notation with the value 9. And so now we have the equation 9 equals negative 2/3 x plus 7, and we need to solve it. We'll begin by subtracting 7 from both sides, so we'll have 2 equals negative 2/3 x. And to solve that equation, we can multiply both sides of the equation by negative 3 over 2. On the right side of the equation, we'll be left with x. And on the left side of the equation, we'll think of 2 as 2 over 1. So negative 3 over 2 times 2 over 1 is negative 6 over 2, which is negative 3. So we have found that the solution for the equation is negative 3, and we will give a conclusion in set notation. The solution set is the set negative 3. In part C, we are asked to evaluate g of 4. By being asked about g, we are now being told we need to work with the graph of y equals g of x. In the statement, evaluate g of 4, by putting the 4 in the parentheses next to the g, we are being told that is an x value. So we'll start with an x value of 4, we'll go to the graph and find a point on the graph that has an x value of 4, and the answer to this will be the y value that is paired up with this particular x value. So in this particular case, g of 4 equals 5. In part D, we are to solve g of x equals negative 3. Again, we're solving, and we're not being told what the x value is. Since we're essentially being asked what is the x value, that tells us the negative 3 we are given must be a y value. So we will go to a y value of negative 3, and we will look left and right, trying to find any points on the graph that have a y value of negative 3. Any point that has a y value of negative 3, then the x value will be a solution for this equation. Since there are 2 points on this graph with an x value of negative 3, there's one at 0, negative 3, and there's one at 2, negative 3, it tells us that the solutions for the equation are 0 and 2. So we will conclude by giving a solution set statement. The solution set for this equation is the set 0, 2. In part E, we are asked to evaluate h of negative 1. Because we are told to evaluate h of -1, we need to be looking at the table that relates to the function y equals h of x. Again, the -1 in the statement h of -1, because it's in the parentheses, is an x value. So to evaluate h of -1, I need to find the x value of -1, and the answer is the y value paired with that. In the table, the x value of -1 is paired with the y value of -3. So the answer to this example, h of -1 equals -3. And finally, part F. We need to solve h of x equals 5. Again, we need to recognize we have not been given the x value, so that is the question, meaning that the 5 we are given must be a y value. So to answer this, we'll look through the y column, finding any row that has a y value of 5, and the solution for this equation is going to be the x value paired with that y value. In this particular situation, the only x value paired with a y value of 5 is -4. So the solution set for this equation is the set -4.